In this video, we're going to work on another example. So the example, when you look at it, the data that we have are like very simple when you look at it, right? So it's like we have N1 and N2, we have two samples from two populations. And then we have X1 and X2. Look at here, there is no X bar, there is no sigma. So it's like that we have X1 and X2, like let's say out of 190 that we have, 158 of them are like the good products, are the products that it's going to pass the control process, like control section of the like process that we have. And then X2 is 107. Here's that test the hypothesis for the P1 minus P2. So it's P means proportion here. So what are we going to do is like that. First, we need to decide that which case we are in. So what do you think? Which case we are working right now? Like with this one, which case it is? You can pause the video and think about it and come back and listen to the rest of it and watch the rest of it. So for this one, when it say in the question actually it said that already, P1 minus P2. So it's going to be, we are looking for the proportion. And when we are talking about the proportion, it means that we are looking for two cases, like for the case number 4, when we have two samples. So I'm going to write down here, it's case number 4, 2, and we have two samples, like data from two samples. Okay, so we want to test the hypothesis. Let's start with the steps, like 8 steps that we had. So here is step number 1. Is like the parameter of interest, right? So the parameter of interest is P1 and P2, like P1 minus P2. Or you can write down P1 and P2. That's, both of them are correct. So I'm going to write down P1 and P2. These are the parameters that we are interested in, right? So I can write down parameters. That's step number 1. Step number 2 is like I'm gonna write down my null hypothesis. So null hypothesis says that P1 minus P2 is equal to 0, or I can say P1 is equal to P2, right? So the proportion of the population. So there is no estimate for this part. Like I don't have a hat as an estimate because it's for the population. So step number 3, alternative hypothesis. So it's like P1 is not equal to the P2, right? Step number 4, the significant, like the level of the significance, because in the question we haven't been given any number, so we consider 95% confidence interval. So my alpha is 5%. Step number 5 is that write down my test statistic, and we know that when we are working with the proportion, we are going to work with the Z table. So it's going to be the test statistic here. It's going to be Z null or Z observed is equal to like P1 estimate minus P2 estimate. In fact, here we have minus, we would have it minus delta like P1 minus P2, but here delta is 0. So, and then on the denominator, I would have like the square root of the P estimate times 1 minus P estimate. And then I would multiply it by the, because I have two samples, right? 1 over N1 plus 1 over N2. So that's going to be my Z observed. And then number 6 is like the rejection region. So for the rejection region, what are we going to do is that we would say, okay, if our, it's the same things that we have, it's two-sided. So if our Z null is less than the minus Z at the half of the alpha, Z observed less than minus Z at the half of the alpha, or Z observed is greater than the Z at the half of the alpha. So that's going to be my rejection region that I would have. And then we are going to have the like number 7. We want to do the calculation or computation. And for the computation, it means that do the calculation, everything. So for example, for Z null, we are going to put the number P1 estimate and P2 estimate. So I would need to write down what's going to be P1 estimate and the P2 estimate here. So the P1 estimate, it's going to be, so I would need, for Z0, I would need to write down P1 estimate. P1 estimate is going to be X1, right? Divided by the N1. And P2 estimate is going to be X2 divided by the N2. So X1 is 158 divided by the 190 is going to give me 0.83. And then 107 divided by the 140, so it's going to be give me 0.76. So I found out P1 estimate and P2 estimate. So, and then I have P estimate. For P estimate, we said that it's equal to the, it was a combination of the X1 and X2, right? And N1 and X, and to X1 plus X2 divided by the N1 plus N2. So we're just going to put this number, this one plus this one, divided by this one plus this one. So it's going to be 0.8013. So after finding out all of this, we can put it in Z0. So what can I do? I can write down the P estimate here, like X1 plus X2. Just because to have like more space here, and to 0.803. And then I can, oh sorry, I have to put this one here. And then I can write down Z0 because I found everything, right? So for Z0, P1 estimate 0.83 minus 0.76 divided by the square root of the 0.8030 times 1 minus 0.8030, and then times 1 over N1 190 plus 1 over N2 140, right? So here I can find out Z0 and my, so like in the test statistic equation that I have, so it's going to be 1.58. Let's say 0.1. So I found that Z0. Oh, I need to find out Z at the Z for the alpha as well. So Z at the half of the alpha was 0.05. So we go to the Z table. I'm going to write down here. Z at the half of the alpha is going to be Z at the 0.025. Right? And then we go to the Z table, and we did it before as well. So it's going to be 1.96. 1.96. So we have 1.96 and minus 1.96. Then step number 8. Is the conclusion. So what would we need to do is that we need to compare our Z at the half of the alpha, and also, where is Z observed here? So Z observed is 1.58. So it's less than 1.96, right? And it's greater than minus 1.96. So minus 1.96. So this one is 1.58. 0.1, and then 1.96. So here, even if you look at it on the curve, so it's like that. Here I had minus 1.96. Here I had 1.96. I found 1.58. Here, 1.58. So we are in the null hypothesis region. So we can make the conclusion. You don't need to draw this one. I just thought that's a good opportunity that I can draw it for you here. So I would say that because of that, we fail to reject the null hypothesis. Okay, so we said that we failed to reject the null hypothesis. If you are interested to find out the confidence interval for this two-sided, it's gonna be you already have everything. Like you calculated your P1 estimate and P2 estimate. You calculated your Z alpha, right? So what you would need to do is that you would need to find out the value for the standard error, and for a standard error, the equation that we had, it was like you would say a square root, and then it would be P1 estimate times 1 minus P1 estimate divided by N1 plus P2 estimate times 1 minus P2 estimate divided by N2. So you would get the square root of it, and it's going to give you the standard error of it. So this is standard error. You would times it by the z at the half of the alpha. You're going to find out the margin of error. And when you find out the margin of error, you're going to say that whatever estimate that you have, P1 estimate minus P2 estimate, plus minus that margin of error, is going to give you the confidence interval for the two-sided confidence interval of it. Okay, so this is the example for case 4. When we have two samples, I'm just going to stand here that you would have all the board. If you want to pause it and write it down for yourself. And that's all for this example. Yeah, I hope it helped you to understand all of. So far we had for all cases. For 1 samples and 2 samples, we have examples.